Okay, so the last video was a long one, but now for this video and for the next, we're sort of going to just pick these couple examples and get into them. And for this video, I'm going to be talking about the support vector machine. And again, this is going to be a bird's eye view. I'm not going to get into any of the math or anything more than just a surface level with this. Conceptually, and again, I'm not going to test you on this. And then after that, I'm going to go into the code, which is, there's not a lot of it, but the difficulty is more setting up your inputs and outputs for this classifier, or for whatever classifier you're using. So I just wanted to cover some of that to help you with your assignment. And support vector machines, these are, or this category is something you can use for your assignment 4. So you might decide that you want to use an SVM, and in that case you can use this code and the code that I'm writing, and that can be one of your implementations of the two. Of course, though, you're not using the same data set. You're using some data set from UCI or wherever, and you're going to reference that data set. And I had some questions before about what I mean by reference. So reference, I just mean we want to see the link. So just take your link and copy and paste it and put it, that's going to be your reference. So you put that down as your reference. So support vector machines. The idea is you have some support vectors which are holding up this structure, which is a hyperplane. Okay, lots of words, but hyperplane, in the simple case of 2 dimensions, is just a line. Okay, and hyperplane is a word that's different depending on which dimension you're in, because it has to do with in terms of mathematics. It has to do with subspaces and things which we're not going to get into for sure. So for the purpose of the class, in 2 dimensions we can just say that a hyperplane is a line, which it is, and in 3 dimensions it's a plane, and then beyond that we call it a hyperplane. But are you going to have to draw a hyperplane on your exam? No. This is just to give you some intuition for what the SVM is doing, and really just intuition, not really going over the implementation details or anything like that. But the idea is you have some support vectors, and these red arrows are vectors, and these vectors hold up this structure, which is your hyperplane, and hyperplane being a line, this black line, with margins extending out. Or maybe we'd say a margin extending out on each side, because it's the same length of D. And these support vectors are from, they're sample points from each class. In this case we have 2 classes. We have a gray circle and a black X, and these are 2 classes of data, and we are separating those classes by this hyperplane, and these in red or maroon or whatever the color is, these are samples from these classes which are occurring at the boundary of the margin. Okay, and when you look into this, you might see that there is also something called a soft margin, where there's an allowance for class data to be popping up inside of the margin. And the reason for that is to allow for some false predictions in order to create a better overall prediction accuracy. But already that's too much for the purpose of this video. So the idea is this line is separating the 2 classes, and these vectors are helping us to support or create our line in this case appropriately. And where it gets more complicated right away is once we get to higher dimensions. So in this case it's pretty straightforward and simple to see, but once we get into 3 dimensions we'll have a plane. In 4 dimensions it's very tough to visualize, and anything beyond that, it's just a lot of mathematics. So you can read through more of that if you want on the scikit-learn site, or another option is to go into, if you're interested, to go into a machine learning course, and they'll probably cover this in a lot more detail. But again, that's a higher level computer science concept, so I don't really want to bog you down too much with that. So how do we code this? Luckily, with sklearn, it's pretty quick. So we can just say from sklearn import svm. And again, sklearn is something you have to import. So in my case, I'm using Linux, Ubuntu. I go to File, I think it's Settings, and then I go to my interpreter and I hit plus, and I can get sklearn from that. Another way to do it is go to my terminal. Okay, right, and you can use this to also install sklearn. Maybe you'll use pip or something, or conda. But yeah, you need to get sklearn onto your machine somehow. And then all we're doing is we are copying and pasting this code from the website, basically to create our SVM support vector machine. Okay, so we can write svc equals svm dot svc, and we're going to use the linear option. Again, don't want to get too much into this. What we really want to get you doing is, I just want to get you set up so that you can use this and be able to compare, for example, an SVM to a neural network or some other classifier. So this is just a copy-paste job, really. To give you a general idea of what we're doing, we're creating an instance of a support vector machine. Already, that's probably too much, because then we get into classes and objects, which we're not covering. But we're creating an instance of support vector machine, and we are fitting it now to our input and output data. What input and output data are we going to give it? So remember, we have a classifier, we're going to train it. So we want to train it on our training input and training output. So we'll say input train, output train. Now what's nice is that we made these in the previous video, so they're all ready to go and to be fed into our classifier, and it's going to fit the input to the output and learn how to associate those two things. So to see then what the predictions are from this SVM, we can say, we can print svc.predict, and what are we going to feed in for our prediction, or where we want the system to predict? We're going to feed our input test, right? Because we want to test our system to see how accurate it is, right? So this is the testing phase. We did the training phase with svc.fit. Now with the testing phase, we are doing svc.predict. Okay, and I can comment out these other print statements just so we can see what we're going to get. So let me print this, or let me run this. I don't know what that error is, line 72. Oh, something is going on with my Python, but this did print. It printed the result. I don't think there's anything wrong with this code. I don't see any errors. Something going on with my Python, but the print statement is what it is. This is what you would want to see. These are all the predictions from our SVM based on our test input. And remember, test input or input test, how many samples were in this? We had 32 to 38, so 1, 2, 3, 4, 5, 6, 7 samples. And what our SVM is doing is it's taking each of these samples and assigning it a class label. So this first one is corresponding to the first sample, the 2 is corresponding to the second sample, and the last one is corresponding to the last sample. Okay, so what we're saying for sample 32, it predicts a class of 1. And we actually do have the correct answers, right? So we can make our confusion from this. We can print output test, right? And we can just check right now. Notice that this is in a different format, so if we want to compare them, like one way to see how accurate we are is maybe turn this into a array, and then subtract these two and just see if all the entries are 0, then that's 100% accuracy, right? But I mean, there's many ways to do it, but just visually taking a look, we have class 1, 2, 1, 2, 1, 2, 1 for my sample data set that I made, 1, 2, 1, 2, 1, 2, 1. So this is predicting with 100% accuracy for this test set. Okay, and you're not going to see 100% accuracy. I mean, you could, but if it's a non-trivial data set, if it's more complicated than what I've given, which it should be, you should see, you'll see varying accuracy, and this is where you're sort of going to compare the different approaches and just sort of comment on which one maybe is more accurate, or however you want to compare the two in your discussion. So that's going to be it for the SVM. For the next video, we will talk about unsupervised learning and the k-means clustering algorithm.